Okay, we are going to make a queue using 2 stacks. So that will basically work like this. We can have some numbers here. Okay, and then we have stack 1 and stack 2. Okay, so if we want to enqueue an item into our queue, then what we will do is we will start by emptying all of stack 1 into stack 2. So for the first time, we're really just pushing the 3 onto stack 2 because we would be pushing it on top of everything in stack 2. And then when we're done with that, we want to put it back into stack 1. So we put our 3 into stack 1. If we want to push our 5 in, then first we want to put our 3 into stack 2, and 5 goes into stack 2, and then we push back to, then we pop them off into stack 1 for our to finish, and so then we get 5 and 3 because we want to mimic the first in, first out behavior of a queue. So then if we're going to put the 6 in, first we want to pop all these off into stack 2, and then we put the 6 on top, and then we pop them back into stack 1. So you get 6, 5, and 3. And if we want to load the 8, then we put everything back in. Okay, and then you put the 8 into 2, and then we pop everything off into stack 1. So you can see it's maintaining that first in, first out behavior. So we're going to be able to pop these off in the order in which they were originally put into the queue. And then if we wanted to do the 10, we would just do the same thing. We would move everything into stack 2, put the 10 in, and then put everything into stack 1. All right, and so then we've maintained our order. Similarly, we could put everything into stack 2, then put the element right into stack 1, and then dequeue stack 2. It really just depends how we want to code that. So let's go ahead and write some code. All right, so let's go ahead and make a class for this. We'll just call it queue from stacks. Okay, and it's going to use 2 queues. It's going to use 2 stacks. So we'll call it S1. And we'll make S2. Okay, and let's go ahead and do our enqueue method first. Our method for adding into the queue. Okay, and that is going to receive its data. Okay, so first we want to see if the stack is empty, and then we can just push it right into S1. Then we can do S1.push data. Okay. Otherwise, and this way we can skip all these other comparisons and everything. Otherwise, while Okay. Otherwise, we want to move everything into S2 before we push anything. So while there's still items in S1, we can do that is greater than 0. Then we want to push everything to S2. Okay. And then after we do all of that, we can push this onto the top of S2. Okay. And then, you know what, let's go ahead and just put it right into S1, just to save an extra pop that we won't have to do then. So we'll push that right into data into S1, and then we will now empty all of S2 into S1. So while there are still elements in S2, we want to push into S1. Okay. And that should take care of our Enqueue. All right, so let's go ahead and write our Dequeue. And if there's nothing in S1, then we're going to throw an exception. It is empty. Otherwise, we can return s1.pop. And if we're going to do our peak, same thing. If S1 is empty, we can throw an exception. Here is empty. Otherwise, we're going to return s1.peak. And that takes care of our peak. All right, so that pretty much is the whole class that we need. So let's go ahead and walk through this and make sure it all works okay. All right, so if we're using our example here, we need to make 2 stacks, stack 1, stack 2. Okay. And then if we're going to enqueue, let's make this a little bigger, 3, 5, 6, 8, and 10. All right, so if we're going to enqueue, then we can say, okay, we've got our 3. And so if s1.count equals 0, it does. We're going to push the 3 on there. Otherwise, we're going to go into our other else, which we don't do that for this one because we did it in the if. And so then we go and we can try to push 5. And we can say if s1.count equals 0, it does not equal 0. So then we go into our else. So while s1.count is greater than 0, we want to push to S2. So in this case, we'll push the 3. Now S1 count is 0. So then we go out of the while because 0 is not greater than 0. And then we say S1.push data. So we're going to push the 5 into S1. Then while S2 count is greater than 0, and right now it is greater than 0, we would pop that and push it into S1. Okay, and now if we want to enqueue the 6, we go in here, S1 count is greater than 0, so we go into our else. So while S1 down count is greater than 0, S2 dot push, S1 dot pop. So we push this 3. And then we still have count greater than 0, so we push the 5. Okay, and then S1 dot push data 6. And then while S2 dot count is greater than 0, we're going to pop. So we pop the 5. Count is still greater than 0, so we pop the 3 and push it into S1. Okay, let's say we want to get that 8. Then we come in and we have more than 0 things in our stack. So we say, while S1.count is greater than 0, let's push everything into S2. So we get 3, 5, and 6. Then S1.push data, which is 8. Oops, I put it in the wrong stack. It's 8 here. Then while S2.count is greater than 0, we're going to pop these and put them into stack 1. Okay. And then let's say we want to enqueue this 10. So first we would come in and get into our else statement here. While S1.count is greater than 0, then we're going to put all of these into S2. Okay, and then now S1 is greater than, got a count of 0, so then we can go in and we can S1.push data, so 10. And then while S2 count is greater than 0, we put these in. Okay, so we have now enqueued all the elements we wanted to, and so now if we go to dequeue them, they should be coming out in, first out order, just as a queue would do. So if S count is less than or equal to 0, which it's not, then we return S1.pop. So if we're popping, we would just return 3. The same if we did the 5 and the 6. If we went into our peak, we still have an S1 count greater than 0. So we return S1.peak, which is 8. And that stays in the stack, or in our queue in this case, because we're just peaking. And we could also go in then, and let's say we wanted to add a whole new number. Then we come up to the enqueue. S1 count is greater than 0. So we go in, S2.push 8, and then push 10. We'd add 4 to S1, and then we would put our 10 and our 8. So we're still maintaining our first in, first out behavior. The complexity of the enqueue is going to be worst case O of 2n, because we have to put everything into the stack and then move everything back to S1. So where n in this scenario is the number of elements inside our stack or our queue. So O2n is our enqueue. Our dequeue is O of 1, and our peak is O of 1. And we're using O of 2n space because we have 2 additional stacks.